What about physics? When you think of physics way that persists and will go together with us in the future.
Particle motion.
Particle motion. So you can think about this function describing particle motion. You can think about that function describing particle motion. Then you think about this function describing particle motion. What are the particles? How do they move? What kind of motion is described by a function? Assigning to each point on the plane a number. You see, the motion in physics assumes a change of time. Something changes in time. If I assign a number to every point on the plane, what is it that I should assume changing in time? Just don't see it. So if it was very convenient to treat the domain as time and to think about particle moving, regardless of where you move, low-dimensional space or high-dimensional space. But if the domain changes, well, it's hard to treat that domain as time, and then it's hard to think about any motion without time. And that, to me, is the advantage of physics. Because you see, algebra gives you at least some way of treating all these derivatives similarly, and suggesting how to treat them in the future. Geometry gives you at least some way. Physics doesn't. And it doesn't fundamentally. It's not a problem about geometry. To me, it's a problem about function. Because in mathematics, we think about all these ideas as functions. Function, function, function. On physics, as you go from these two cases to that one, you really have to change your thinking about what it is. I cannot think about any interpretation of the function that will capture all three cases. It's usually the motion in this case and something else in that case. And if you cannot interpret function consistently, and then for the next case we study, from plane to a plane, we will have to reinvent something else in physics. A new situation, a new idea about what the function is. Well, that's really hard. In the sense that if every time you study something, you have to reinvent something else. That's not helpful. Does you think that is the power of mathematics? Its superiority over physics. And it goes at different levels. And I'm not saying that mathematics knows something more than physics, or the other way. I'm not comparing the knowledge, the facts, or something else. I'm comparing the helpfulness in learning. Because in learning, it's good to have a systematic way of doing something. It's good to learn something here and being able to bring it to new situations. And even to those situations you never saw before. But it's good to know that, well, you can still use those, right, those concepts. Well, if physics doesn't give you this role of consistent way of thinking about the function, about derivative, about those complex concepts, well, that's really a disadvantage. So what I'm basically predicting is that in the future it will be increasingly difficult for me to present physics point of view in a consistent way. Every time we go to a new situation, say a new function, mathematically it will be a continuation of the previous algebraic or geometric concept. Physics, I will have to invent either this pressure of gas or temperature of a plate or fluid flowing there or something else. We will have to bear with it. I'll try to avoid electricity. My experience is that many people don't like electricity. Oh, if that's not the case, I'm really more than happy to talk about electricity. Well, electrostatics, so something simple, not electromagnetism. All kind of complicated effects.